indications of the nature of roots. So we know now that the nature of roots can be real or non-real, equal or unequal, rational or irrational. So now I can apply those sums to nature of the roots. If I ask you a question, these are examples of that. If I ask you for which values of m will this quadratic equation have real roots. Now guys, that should be the key. When you're reading the sum, it should take you not to exponents, not to simultaneous equations, not to finance. It's definitely, I'm busy with nature of the roots. So I want your brain to be brainwashed, to hear the question and say, oh, nature of the roots. It's got to be something to do with the what? The discriminant, delta. So if I'm asking you when something will have real roots, that m is now a variable. Usually we've got a quadratic formula with an a and a b and a c, but the c is now an m. I'm asking, for which values will it have real roots? The real roots come in when you know that the discriminant is what?
Equal to 0.
Equal to 0? Bigger or equal to 0. Those are real roots. So whether, if it's equal to 0, they're equal, right? Not equal to, there's two answers, but that's not the question. I want to know real roots. So real will be when that discriminant inside of that formula, quadratic formula, is bigger than 0, and it can be equal to 0. It's still going to be a real answer. That's what your first mark is going to be, that you know that. But what is the discriminant? What is delta? B squared minus 4ac must be bigger or equal to 0. So I've got b equal to 6b. A equal to 1. C is now m. Guys, C is the value that's a constant at the back, but C is now a placeholder variable. Your A is always in front of the x squared. Your B is always in front of the x, and your C is the thing that doesn't have x. It's now something that has an m, but the whole thing is the value of your C. Must still be bigger or equal to 0. What have I got here? An inequality. What type of inequality? Let's just look at it. 36 minus 4m. What type of inequalities do you know? Linear, quadratic. If it's quadratic, that thingamajiggy. Okay? Is that it? This is?
Linear.
So how do I solve linear? Take the 36 across. Why do I take the 36 across? Because in inequalities, it's necessary for you to know that it's bigger than or smaller than, and you're not saying bigger than, but you're thinking smaller than. So you need to read from the left-hand side. So I'm going to divide by negative 4, which will change the sign around. Why?
Because you divided by a
Otherwise,
negative.
to make it true. Right? Otherwise it's not true. And that answer is 9. So I'm going to ask you, give me the highest number that it can be, or how can I put this to find out? Or put this on a number line, so that I can know whether you know that this is a smaller than sign and not a bigger than sign. So if I say represent your answer on a number line, you'll go at 9 and show me it's included and going to the left. Then I know you know that it's smaller than. Because usually that's what we test. And when you swap it around, and when there's 9 bigger or equal to m, do you still know that that is m smaller than 9? And that's why I tested over here. It's fine if you write the answer like that. It's fine. But do you know that this is what it represents? Okay. Another one, if I ask you, because the questions will now just vary. Give me a value for, and now the b is the k. See it? What is a? The value in front of? X squared. The b value is in front of? X. And the c value doesn't have x. Are you with me? So the b value is the unknown. And I want to find the value of k. Do you see my question there says, find the value of values. So there can be more than one answer. There was a lot here. Alright, so which value of k will with this be to have equal roots? What does equal roots entail? Will you sit in a test and think, oh, discriminant? Equal roots, nature of roots. Look at the discriminant. And for equal roots, what must the discriminant be?
0.
So you know in the back of your mind, you've got that little formula. And there sits your discriminator, your discriminant, that says what must it be. For equal roots, this plus and minus won't be two different things. It'll just be plus and minus nothing, which will make it just be one answer. Just substitute your B and your A and you've got one answer. For equal roots, one answer. So that's why you get a mark for knowing it's equal to 0. And again, substituting the b squared minus 4ac with the values that it is. But this time it's an equation. This was an inequality. Right? So the b value is? Negative k. But squares in any case is going to be k squared. Luckily. And then a? 1. And c? 1. Right? Happiness?
Yes.
So we've got k squared minus 4 equal to 0, which is a what type of an equation? It's the difference of squares. It's a quadratic equation, so you've got to factorize. So we've got two options here. You can say k minus 2, k plus 2 for factorization, and your answers would be k equals 2 or k equals, meaning when you go right there at the top and it was 2 or it was negative 2, the answers will be the same answer. I don't know what the answer is going to be, but there will only be one answer, not 2k answers. That's not what the sum says. 4k put in there. That equation will just have one root. Sketching it will just touch the x-axis. One root. Okay. So if, what else about, oh yes, I wanted to say alternatively, can't I say k squared equals 4?
Yes.
And then
Root.
root it? But then you must forget about the plus and minus, which is the same answer. Right.
Happiness.
Little bit more difficult, because guys, we did now real, you said big or equal. Equal, you said equal to 0. Non-real, you would have said discriminant, less than 0. Are you with me? But now, I want you to prove for me that this expression, oopsie, words, right? A value, 1. B value,
K minus 2.
okay, it's nicely put there for you. And C,
K 1.
Minus
K.
and minus K. Remember what A and B and C are. A is the value in front of the x squared. B is the value in front of the x. There's a lot of them. C is anything that doesn't have the x. Could they be a minus K plus 1? Then that was your C value. Everything that doesn't have the x in. So now I'm saying prove that this has real roots. Real roots must bring you to nature of roots, must bring you to discriminant, must bring you to b squared minus 4ac. But now I don't know what it looks like. I'm saying show that it has or prove that it has. So I don't know if it does. If it does have real roots, it should be that the discriminant is bigger or equal to 0. But I can't say that. I've got to prove it. So now let's look at it. B being k minus 2. A being 1, C being minus k. Let's, now what? Because it's not an equation. This is the discriminant. It's not an equation. You can't go around trying to solve something. It's an expression. I want to look at this expression and I want to determine whether it is positive or equal, bigger than 0. So when I have to time this out, right? So we're going to have k minus 2 times k minus 2. This will be plus 4k. Agreed?
Yes, ma'am.
Minus times a minus, 4 times k. And this will be k squared minus 2k minus 2k plus 4 plus 4k. And so the answer would be k squared, if we add up the like terms, k squared plus 4. Now, how will I prove mathematically that this is definitely bigger or equal to 0? Yes.
Anything squared is going to be positive.
Fantastic. Am I writing that in English? Anything squared is definitely positive. You're going to say, and here's my conclusion. K squared is definitely, this is the way I write it. But equal also to 0, isn't it?
Yes, ma'am.
Because k can be 0. Something squared can be definitely positive or it can be 0. But if you add something to that, it'll definitely just be bigger than 0. So what have I proven? That the discriminant is bigger than 0, so that is why real roots. That's the sum. Freaky? A little bit different? Okay, but it's all about knowing real roots must be bigger or equal to 0. Bigger than, still real. Alright.